knew this was gonna be a drag.
I don't even know where to start with this video. After rewriting the framework about 9 times, I decided to use a production line to help structure how the velocity gets modified. In essence, it works by taking an initial value, applying a modification to it, and passing it down the line. If for whatever reason you needed to take the object off of the theoretical belt, simply specify an operation to return from. To properly utilize this class, a more component-based design is required, but I think that fits better inside of Unity anyways. The hardest part about this lab by far was the drag, because I'm stubborn and wanted to know the most complex way possible to accomplish something already implemented. One of, if not the hardest things about it was the part of the equation that said cross-sectional area, and for something as simple as a sphere, it's just pi times radius squared. Once you get a shape that projects a lot more interestingly than a sphere, it becomes pretty complex. Simply put, you need to use any convex hull meshing algorithm. I chose GAME2005, and then use an algorithm on the resulting polygon to calculate its area. I chose the shoelace formula for that. After all of that, and an algorithm for sorting by the local x-axis of the normal's plane, you get a float. With that incident out of the way, all that's left is to plug in the numbers. By taking the area, half the squared speed, and an arbitrary drag coefficient, you get the drag force. The vertical drag is slightly different, but the core concept is the same. By taking the force, but subtracting it from the object's weight, you get the vertical drag. Simply add them together, subtract it from the initial, and boom, you're done.
A drag queen? A drag queen! I am the queen of drag!